So this is an industrial cooling system for a data center. And right now, as you can hear it, it's kicking on. Most data centers run their cooling system like this at full blast. And if you can hear it, most of the time servers are not even ramping up. Somewhere in the world, a data center is running its cooling system at full blast, cooling down servers that are not even breaking a sweat. And this is happening everywhere. In fact, data centers consume 3% of the world's total power consumption today. And this is going to increase dramatically over the next 5 years. A data center will use 40% of its total energy consumption just for cooling alone. And remember, all this cooling is being used to reduce the temperature of servers that run AI. But what if AI can be used to fight the inefficient cooling systems inside data centers, using AI to make AI more efficient? Let's talk about it. So here's the problem with traditional data center cooling. You'll have a raised floor where servers and HVAC equipment will be placed. So here's your HVAC, here's your servers in the middle. These HVAC systems, called cracks, will send cold air underneath the floor. The cold air will go through the servers, they will get heated up, and they will come out, usually going through the roof or back to these HVAC systems. The problem is this. Some of the cold air that's going through here and gets heated up, as shown here, will bleed into this area, and you'll have cold air and hot air mixing. This creates hot spots. So what do data center operators do? They crank these HVAC systems in their auto mode, and they overcool the system, leading to even more waste. So if you could separate the hot air and the cold air, you can create a more efficient data center configuration. Let me show you what that looks like. There are many different types of cooling configurations in the data center industry, but traditionally you have a raised floor configuration with either hot aisle or cold aisle containment. So for the first configuration, we're gonna showcase a hot aisle containment, meaning basically the exterior is your data center, you have a raised floor a few feet above the ground, you have a plenum or an area above your data center equipment. In between your raised floor and your plenum is where all your data center equipment will be, your cooling systems on the perimeter and your servers in the middle. This is what happens. Servers in the middle will heat up the air in a hot aisle containment. This is your hot aisle, and all the heated air will be concentrated in this area. It'll rise through the plenum. Some of it will go outside, most of it will go back into the cooling system. The HVAC and the cooling system will cool down the hot air, bring it underneath the raised floor and into the cold aisle. But the cold aisles in this configuration is not contained, it's cold aisle flooded, meaning a lot of cold air goes through this area. Once the cold air goes through this area, it gets heated up by the servers and then gets concentrated again, and the whole loop runs once again. This is some of the most efficient type of air-cooled configurations in the data center industry today. PG&E did a study where they retrofitted containment inside a data center that didn't have this config and saw a 30% improvement in efficiency. So how can AI be used to make such an efficient system even more efficient? Well, the inefficiencies in this system is not on the configuration of the physical layout, but rather the control and the predictive knowledge of these HVAC systems. So these crack units, or computer room air conditioning units, usually have 3 different types of ways they control their cooling. They can do it off of sensors, they can do it off of schedules, or they can do it off of manual configurations. The cooling system usually has a hot air return sensor above here. This is your return sensor. This sensor is pre-configured with a set point that's manually operated. Once this return sensor of the hot air gets a reading, internally it will set points and even fan speed on how hard this cooling system runs. So that's where you will have set point logic and your cooling capacity set. Now this is what's cool. That configuration worked really well 5 years ago. Only problem is servers, like AI servers, are ramping up quite quickly. What if you could use AI to control HVAC systems to be more efficient and aware of the data center environment. Right now, these HVAC systems operate on their own sensors in isolation. Now, what if these systems could be configured to sensors in more ideal locations? And what if they can be connected so they become more aware of each other? In data centers, to accomplish this, these need to become usually the same brand, or there needs to be a software that connects the intelligence of these units. Now, today, that's just not the case. These systems are usually different brands. They do not communicate or work with each other. Now, you can solve this by installing more sensors inside the environment so you can grab more data and manually configure your system so these two units work together. By using machine learning and different types of sensor data, you can get two separate systems working with each other, which is really cool. You can connect these systems to a central brain. This will send feedback loops to the AI system back to these HVAC systems. So now they're aware of what each other are doing. This is one way that AI can be used to connect industrial HVAC systems. Here's another way that's quite interesting. Remember how I said these HVAC systems have internal sensors? The sensor is a lagging indicator. So auto mode usually sets fan speed, set points, and how these systems run based off of their own return sensors. But with sensor data and machine learning, these systems can now become more predictive rather than reactive. HVAC systems using AI can predict what the temperature in this zone will be or how a server will react. By doing so, you could ramp up or down this system. You can tune a system to what's needed rather than being overcooled. So what's the best approach? Well, it depends. Usually a combination of containment and using AI control systems will get you the most efficiency. Here's Chase, Fluix's CTO, with more information about how AI can optimize cooling.
Current control systems are static, where in reality the environment in which they inhabit is dynamic. So in order to show how we beat the state-of-the-art, we built this lab with real data center equipment. This is Fluix's AI autopilot called A.I.M.I. In a minute, we will turn it on and showcase some of its capabilities. For now, let me walk you through some of the data A.I.M.I. captures. A.I.M.I. can integrate with any sensor type and equipment and uses the AI models to make real-time control adjustments that ensure energy savings while maintaining safe conditions. A.I.M.I.'s operations are much more efficient than normal operations of HVAC and water systems you see today.
Here is a simple demo. Our HVAC unit is currently running at 100% capacity despite being in normal operations, wasting a tremendous amount of energy. As you can see, that fan is blowing constantly, and the compressor is running near 100 the entire time. That's because industry standard HVAC units like this one usually only use their own return air temperature set points, rather than the full knowledge of the environment. With an intelligent AI system reading from multiple sensors at different locations in the environment, taking into account different equipment and energy readings, we can get a more holistic view of the data center and optimize the HVAC's operations. In essence, this is what A.I.M.I. does. Now watch what happens to the HVAC unit when A.I.M.I. takes control. Sensors feed data to our AI model, which predicts and adjusts system load instantly. You hear the HVAC ramp down, and on our dashboard, you'll see the energy savings in real time. 52% reduction.
Quite frankly, we need more energy for AI data centers. And every watt that's wasted in cooling doesn't go towards GPUs. So by making data centers more efficient, it's not just about saving money. It's about increasing compute capacity and even revenue. If you found this content helpful, make sure to click the like and consider subscribing. The whole point of this channel is to demystify data centers, and we'll be coming out with more content talking about AI, energy, and data centers. Let us know what else should we cover in the data center industry. But until next time, peace.